some of you maybe some of the lecture maybe a little bit above your head, which means a little bit difficult, which we understand. But I do encourage you to grab as much as you can. At the end of the lecture, if you have questions, if you could ask in English, that would be fine. But if you cannot, Dr. Yuan is willing to translate Vietnamese, okay? So I encourage you to ask questions. As I said, there's no stupid question. I mean, sometimes it's an Asian culture, we always be discouraged about not asking questions, okay? But if you want to be a scientist, you need to overcome that barrier, okay? Communication is a key point, and you need to communicate it with your fellow scientists, okay? And so, ask questions. I really encourage you to ask questions, and including Dr. Yang's lecture today is about biostatistics, and there's probably a lot of things, if you never learned biostatistics, this is a little bit hard. But biostatistics is really a very important tool for us to do research, especially here, many of you may be involved in epidemiology or even the simple, like our lab work. Some of these biostatistics tools is very important to use. Okay, so enjoy the class. I'll let Dr. Yang start.
Xin chào. Good morning. So today's my turn, and this is going to be my first lecture to you all in this series. And today I am going to talk about a little bit about statistics and the use of statistics in the biomedical research. Here, this is the introductory slide. Okay, the title of this talk is, I call it, I am at least 95% sure. But why do we say that? Because in biomedical research, in fact in many types of scientific research, we always need to convince people and use statistics to analyze, to demonstrate that whatever I'm telling you in this paper, whatever I'm presenting to you, that I am at least 95% sure that there's only less than 5% chance that I would be wrong. So, my name is Jim Young, and I have an MD degree, PhD degree. I'm also a registered pharmacist. So I have trainings in pharmacy, biomedical research, and also medicine. I belong to the Department of Emergency Medicine and also the Department of Endocrine Neoplasia and Hormonal Disorder. So I have joint appointment in 2 departments in MD Anderson Cancer Center. So as an acknowledgement, we thank the Vietnam Education Foundation for the financial support, and we thank the Vietnam Academy of Science and Technology in Hanoi for helping to organize this course. And we of course thank the support of our parent institution, the University of Texas MD Anderson Cancer Center. So as a disclaimer, I am a physician scientist and I am not a statistician. So therefore, what I'm presenting to you today is only my personal perspective and preference in terms of how to use statistics in the pursuit of biomedical research. And by no means I am any expert in statistics or biostatistics. So as an overview, Today, I am presenting to you some basic statistical concepts and some common methods for quantitative analysis. And perhaps things that are more useful to you would be the how to present data, what's the tips on graphical presentation of data, as well as some common flaws and mistakes in statistics that people encounter or people would frequently commit. And these are the pitfalls that you would try to avoid. So to begin, I'm going to talk about what is medicine. So as a physician, when we see the patient, well, very often we make the diagnosis based on physical examination, and then we order some tests, some imaging studies to try to confirm what we think, what our initial impression of the diagnosis is, and then based on the diagnosis to plan the treatment, whether it's medicine, surgery, or both, or etc. So in order to do that, all this thinking process behind all this physical examination, testing, laboratory testing, imaging studies, all this is based on science and technology. So this is a timeline of the history of development of Western medicine. Back in the old days, in the time of the Greeks, or even before, Western medicine is not much different from Eastern medicine or Indian medicine or herbal medicine. It's based on experience, based on the teaching of the knowledgeable people before us. And over time, what we learn from our predecessors, sometimes things get lost from generation to generation. Back in the old days, bloodletting, leeches, many practices that are really based on tradition and not really based on science or substantiated by science. And then the Greek philosopher Hippocrates really is considered the father of Western medicine. And he is a great philosopher. And it's the philosophy of how to pursue knowledge, as well as his ethics of how to take care of the sick people, that really we honor him and call him the father of Western medicine. And in fact, the dictum of do no harm is coming from his philosophy. And in Western medicine, in America, many of the medical schools, when we graduate from medical school, before we become a real doctor, we have to take the oath. We have to take the oath of Hippocrates. The first thing is do no harm. And then in the development of Western medicine, here is a drawing of Leonardo da Vinci. The anatomy, the study of the human body, the understanding of the physiology and the anatomy is really formed the scientific basis for Western medicine. And then over the years, building on that foundation of knowledge and the philosophy of how to acquire new knowledge, then the Western medicine is becoming more and more based on science and technology. And then you have the developments of discovery of penicillin that really revolutionized and saved a lot of people from infectious diseases. And then the inventions of technology of imaging from CAT scan. CAT scan stands for computer axial tomography. They're basically using X-rays to compute a matrix of radial density and then putting the dots back together to form an image to represent a slice of the body. And then these slices is stacked up so that it allows you to have the imaging of the internal organs of the person. And then, since the discovery of the DNA, then the molecular era begins, the molecular biology era. And then now we're looking at using genes and genomics, transcriptomics, and all these new technology to try to understand the body and acquire new knowledge to try to tackle the difficult problem of cancer. And also, technology is also making big advances. Down here, I'm showing this robot. This is called the Da Vinci robot. Okay? So, this robot is sitting right here with the robotic arms controlling probes that are sticking through the belly into the abdominal cavity, and the surgeon is sitting here looking at the computer screen, controlling the robot and do surgery. Okay? So with this technology, the robot can be in Timbuktu, Africa, and the surgeon could be sitting in America and do the operation over the internet. So medicine is both an art and science. Okay? So with the advance in science and technology, Western medicine has come a long way. But still, there is the aspect of arts and humanities. The patient-physician relationship. Okay? No science and technology can replace that. Okay? A personal-to-personal contact and the rapport between the patient and the physician. There's no science